So today we are taking a look at rate of change and solving for y, trying to get ready for our Algebra 1 STAAR test. So let's just take a minute to review a couple of the basic things. So one of the first things that we need to be familiar with is our slope-intercept form of the equation for a line. So this equation is on your formula chart. You just need to remember that its name tells you essentially what's important about it. From this formula, we can see the slope, which is the m, and the y-intercept, which is the b, so where you cross the y-axis. Rate of change is code for slope. Okay, so when you see rate of change, you need to think slope. So slope moves from left to right. Think about the way that you read words on a page, from left to right. So if you're reading a graph from left to right, if you are going up, there's a positive incline. If you're walking up that incline, that's a positive slope, positive rate of change. So y going up from left to right, that's what positive looks like. If you read your graph from left to right and your line is going down, or any graph is going down, right? In the case of linear, that's a negative slope or decreasing. Here we have zero slope, and so zero, that's going to be a perfectly horizontal line, so very easy to walk along, all right, versus undefined, which, we're having a bad time, all right? So can't walk along an undefined line. So Hoy and Vux were nice little ways to help us remember some of the important things about these two special case lines. So Hoy, horizontal, zero slope, y equal equations of these lines. So y equals a number would be the type of equations if you needed to write the equation for this line. So they look a little different than our y equals mx plus b equations. Same thing is true for Vux, vertical, undefined slope, x equal equations. Okay, so this would be the equation x equals a number, and that would just be wherever the line crosses the x-axis or the y-axis. Okay, so just a little refresher on that. So some of the ways that we found slope. So we had slope given a graph, and so when you're looking at a graph, we would need to find, we could think of them as two perfect points, right? We really just need 2 points. The only wrong way to do this is going to be to pick a point like this, right? So just notice that something like this or like this, it doesn't hit the corners of our grid cleanly. So we want to look for points that are going to hit the corners so that if I wanted to make an ordered pair for that location, it would be whole numbers for my coordinates for x and y. Okay, so any 2 points, there's more. You could have picked points over here, this one. So you have several to choose from for this particular graph. From there, we're going to count rise or fall. So really what we're saying is just up or down, right? So to go from one point left to right, from one point to the other, I have to go, in this case, up 1 unit, right? So vertically up 1 unit to get on line with that next point. And then I have to run to the right 1, 2. So I'm going this direction 2 units. So my slope, my rate of change, reading the graph, is 1 over 2. Up is positive, right is positive, so that's going to be a positive 1 over 2. Friendly reminder, if the slope is a whole number, so let's say that you have a slope of 2. If your slope is 2 and you needed to see it as a rate of change, or if you needed to count rise over run, don't forget that we can write all whole numbers over 1, and then that way we can see that rate of change. So up 2, right 1, which is just the opposite, right, of up 1, right 2. So whole numbers over 1. Rate of change equals slope. Okay, so rate of change, slope, rate of change, slope. When you see the words, what are the rate of change, show up in problems, you know that that's just a code for find the slope. So we have another graph here, but this one's going to be more of a real world, application type of problem. They'd probably give you some words, some context with a picture like this. But then they would say something at the end about find the rate of change, or what's the rate of change in this problem. And so this is the same skill set as this. Yes, we have time on one axis and distance on the other, but is the skills you need, we just need to go from one point to another. So picking our 2 points. Here they kind of bolded them for us. You can pick any two. So we could go from here to here. You could start here and pick a point up there. Once we simplify our fraction, we're going to have equivalent answers as long as we count our rise and run correctly. So if I wanted to just keep it really simple, from here to here, on the grid, it looks like I just go up 1 unit over 1 unit, right? But if you really look at what we're counting by, I went from 0 to 80. So I actually, according to this graph, I went up 80. That's what 1 unit stands for. So that's what's important, what's on the axes. From here, on my time, again, it looks like I went over 1, right? But really, I can see that my over from 0 to 2, I'm counting by 2's down there. So I went up, so positive 80, right 2. And so dividing that fraction out, simplifying that, gives me a rate of change of 40. Okay, so that's my rate of change. That's my slope. And so just really emphasize this point, right? The cautionary tale here. They don't always go by ones, and you're definitely going to see problems like that show up where you're not counting by ones. So use what you're going up by, okay? Now, next, rate of change from a table. So when you have a table, there's a couple of ways you could handle this. Remember that, again, slope, rate of change, same thing, right? From a table, you're finding the change in y over the change in x. And we wrote that like this, a little triangle, so representing change. So the slope is the same as finding the change in y. So what we change going up and down over the change in x, how we move going left or right. You could also bust out your handy dandy slope formula. You have that on your formula chart. So that's the change in y, right? So y2 minus y1 over x2 minus x1. So we could always use that. This is m equals, and again, on your formula chart. So if we, depending on your preference here, can go a couple of different directions. So we could pick 2 ordered pairs, and we could label our coordinates, and we could plug into our slope formula and then throw that in Desmos to simplify it. We could also do our change in x by hand along the table, as we've practiced a couple of times. So figure out, okay, what are our numbers moving by? So when we're dealing with, the change in y, we'll start here because this one's a little easier to see. We can tell that our numbers are going down, right? So from 96 to 60, 33, 15. So I know that I'm subtracting, taking away, going down. The difference between the numbers, so from 96 to 60, that's going down 36, okay? The negative ones are trickier to see a lot of times. So if we think about a number line though, if you think about a number line and you've got negative 20 over here, and then you're moving this way, and eventually you're over here at negative 2, think about what's actually happening with those numbers, right? They're getting bigger. So this is actually, this column, it's getting less negative, so it's actually going up. And so then I'm thinking about the difference between the numbers. So from 20 to 12, that difference is 8. Now you could technically keep going, you could calculate all of these, but I just want to remind you guys that you really don't need more than one set. You can use multiple to check yourself, but for a rate of change for a line, that's constant. It should stay the same. So you can pick your 2 favorite points, calculate the change, and then use that change to actually set up our little formula, change in y over the change in x. So the change in y on top, careful with that, right, is negative 36 over the change in x, which was a positive 8. So your answer choices are going to be simplified. So we need to be able to reduce that fraction. So negative 36 divided by 8. If you have decimal answers, that would be the answer you're looking for, but don't forget Desmos can reduce for you. So it'll simplify that fraction if you use that key. So negative 9 over 2, that is going to be the answer choice that we would be looking for. Okay, that's our winner. That's our rate of change. So we're going to take another one with a table here. This was from a release STAAR test from a couple years back, and this was a griddable, so there weren't any answer choices. So automatically scary, right? Let's read through it. The table shows the linear relationship between the balance of a student's savings account and the number of weeks he has been saving. Based on the table, what was the rate of change of the balance of the student's savings account in dollars and cents per week? Okay, so that sounds way worse than this problem actually is. I know that they didn't give us, X and Y, but X and Y, right? So weeks, anytime they write them out like this, X is on the top, Y is on the bottom. So based on the week, the output is the balance. So just looking at that as far as our change in X and our change in Y. So we just need one round of changes, right? So as we know that rate of change means slope. So we're trying to find the slope of this line. When we're looking at our table, we can pick any points we like. These are probably the friendliest. So what happened from this week to that? So we went up 1 week, so plus 1. What happened in our savings account? So 32 to 39 is up 7. And so just creating our rate of change, which is just the change in Y over the change in X, 7 over 1, or just 7 is our answer. So we'd be gridding 7. Now, the other option, for those of y'all that remember the worm, you do have the option to let Desmos bail you out of having to calculate slope or come up with equations from tables. This is only good if it's going to be a linear, relationship, which we know that it is because it told us that right there. But when it is, we can input our table and use the worm if we recall how to do that. So I'm going to take us through that just so we have a little refresher here. Take that out. So to put in a table, we hit the plus sign, select table, and then we're going to type in our data points. So just using all of the information that they gave us in our table for the problem. And then we've got 32, 39, 53, 74, 88, and 123. Okay. So when you come down to your next line here, whenever you are trying to use the worm technique to get it to create the equation for you, we need to type in, we need to tell Desmos what to do with these data points. So we use Y, but this is the tricky part to remember. You need to say Y1. So we need to tell Desmos, hey, you need to use these values for Y1. So these are the numbers to use. Equals MX, again, we need the 1. So we need to tell it specifically X1, plus B. And if y'all can guess what has went wrong here. So we're so used to saying equals, right? So we need to tell Desmos what to do with that information. So that's why we use, instead of equals, we use the worm. So the worm is like the little operation that says, hey, calculate what the equation is, a y equals mx plus b equation from these data points. And so what you'll see here is they'll spit out what the m is and what the b is if you were to need it. In this case, we just need rate of change, so 7. So for something like this one, it confirmed our answer. If you understand rate of change by hand from your table, especially with these numbers, which weren't too bad, this wasn't terrible, right? So it was faster to do change in y over change in x and get 7. But let's say you don't trust yourself or you want a way to check, the worm can calculate your slope, your y-intercept, technically that whole equation, if you remember that process.